The objective of this lesson is to explore line segments and angles on rectangular and isometric grids. Students will describe and draw perpendicular and parallel lines and line segments in two-dimensional shapes. In previous lessons, students became familiar with lines and line segments. In this lesson, we will be examining two special sets of lines and segments, perpendicular and parallel. Parallel lines are lines that are the same distance apart between any two corresponding points. You might say that these lines never cross. Examples might be vertical lines on a window pane or train tracks. Perpendicular lines are lines that intersect or cross, but they cross at exactly a 90-degree angle. Examples could include the vertical and horizontal side of a picture frame, or the vertical and horizontal intersections of the mortar lines between bricks. Take a look at this grid paper. Do you see any parallel lines? Notice with your child that all of the horizontal lines are parallel to each other. The vertical lines are also parallel to each other. However, where a vertical line and horizontal line intersect on this particular paper, they intersect at a right angle. We can check this by using a protractor. Remember, a right angle measures exactly 90 degrees. To begin drawing parallel lines, let's take a look at this dot paper. What do you notice? You might say that the dots are equal distances apart. Also, when we compare it with our grid, notice that the points correspond with the intersections of the lines. Let's use this paper to create some shapes and look at the lines. Let's begin by drawing a line segment here. Then let's draw another line segment next to it. Notice that the lines are the same distance apart for the entire length. This means that they are parallel. We can indicate this by drawing matching arrows on the lines. Now let's connect the sides. Notice that the sides we just drew are also parallel to each other. We can indicate that these line segments are parallel to each other, but not to the first set of line segments by drawing a double arrow on each. However, comparing them with the first set of line segments, we notice that they intersect at a 90-degree angle, which means that these lines are perpendicular. We can indicate that they are perpendicular by placing a right angle symbol, this small square, at the intersection of the line segments. What shape did we create? A rectangle. Understanding the relationship of line segments and their angles will help students to make generalizations about shapes. For example, from our rectangle, we could say that in all rectangles, opposite sides are congruent and parallel. They also have 4 congruent angles of 90 degrees each, and each side is perpendicular to the two sides it intersects. Let's create a different shape. What if I create 2 parallel lines with different lengths, and let's mark them as parallel with the arrows. Now, when we connect these sides, notice, are these sides parallel to each other? We can see that the lines are not the same distance apart. At one end, they are getting closer and closer, and the other end, they are spreading farther apart. Remember, to be parallel, they must be the same distance apart for the entire length of the line. This means that these segments are not parallel. Look at the intersections of the line segments. Do these intersect at a 90-degree angle? We can check with a protractor, or just lay it over the grid paper to compare. Can you see that this angle is larger than 90 degrees? And this angle is smaller than 90 degrees. So these line segments are not perpendicular to the sides they intersect. However, take a look at the opposite side. This side does intersect the two sides at a 90-degree angle, so it is perpendicular to those line segments. Just for fun, let's change the grid paper and dot paper that we were using. Take a look at this isometric grid paper. Can you find any parallel lines? Notice the horizontal lines are parallel to one another. Also, there are diagonals that are parallel to each other. But what about perpendicular lines? In the other grid, all intersecting lines were perpendicular. On this grid, the lines do not intersect at 90-degree angles. Now take a look at this dot paper. Take note that the dots are still equal distances apart, however the alignment is different. If we lay it over the grid paper, the dots still correspond to the line intersections. Using this paper, let's create a set of parallel lines. Notice that even though these lines are not vertical or horizontal, they are still the same distance apart at corresponding points, and so they are parallel. Give your child the opportunity to look at lines that are turned in different directions. Students are often confused when shapes and lines are oriented or turned differently. Now let's draw another set of parallel lines that will intersect with the first set of parallel lines. Are these intersecting lines perpendicular to one another? Reason with your child and discuss how they know that they are not perpendicular. Now notice the shape made by these intersecting lines. Do you recognize it? Your child should quickly identify it as a parallelogram. Take time to discuss the relationship of the lines and angles and make some generalizations about the shape. The objective of this lesson was to explore line segments and angles on rectangular and isometric grids. We were able to describe and draw perpendicular and parallel lines and line segments in two-dimensional shapes using different types of grid, dot, and isometric paper and visualize the line relationships.